So, welcome to the next lecture of Math 120. In the previous lecture, we have discussed echelon forms and reduced echelon form of an augmented matrix. If you have any question, you can ask me. Today, we are going to start or discuss homogeneous linear systems. Homogeneous linear systems are the systems in which the right-hand side is always zero in a linear system. Means the constant vector which we usually write on the right-hand side of a linear system, that is always. I hope you know how to write a linear system in a matrix form. This is the general non-homogeneous linear system. Whereas if right-hand side vector, it contains all the entries zero, then the linear system is said to be homogeneous linear system. Okay. If B is non-zero, then it is called non-homogeneous linear system. Now, one very important thing about the homogeneous linear system is that homogeneous linear systems are always consistent. Homogeneous linear systems are always consistent. What do we mean by consistent? Consistent means that either they have one solution, either they have only one solution, which is the trivial solution, okay, which is always, you can say, a trivial solution. Trivial solution is what? That is x is equal to 0. If we take all the variables equal to 0, then this must satisfy that homogeneous linear system, and this is called trivial solution of the linear system. Otherwise, the second possibility is what for the consistent linear systems? It has, or homogeneous linear system has, infinite many solutions. Okay, infinite many solutions. So there are two possibilities for the homogeneous linear systems. Either they have one solution, unique solution, which is the trivial solution, means zero solution. The other thing is that the homogeneous linear systems have infinite many solutions. Why is this so? Why a homogeneous linear system cannot have the third possibility, means solution does not exist? Can anyone tell me why that third possibility is not possible here?
Sure, because it has to be consistent, and if it has infinite solutions, then 0 would be equal to infinity, which is not possible.
I don't get your point. Can you repeat it?
Sir, pata nahi, it was a guess because you said that they're always consistent. So left-hand sides always have to be equal to right-hand sides. So 0 cannot be equal to infinity. So it will be inconsistent.
No. Sadullah Kundi, you tell me. You raise hand.
Sir, a matrix which has a consistent solution means that it does not have a leading entry in the rightmost column. So since 0 isn't a leading entry, it will have a consistent solution.
Okay, next, Hanzala, you tell me.
So because the right-hand side is 0.
Yes, you can say that. So if in an augmented matrix, we get a row which contains all the zeros except one at the end. this is what happens when we obtain such a row in a echelon form or reduced echelon form of an augmented matrix. We get all the zero entries in that particular row except the last one. I told you in the previous lecture at the end, whenever we have such condition or such situation for any augmented matrix, the last row, it has all the zero entries except the last one. Last one may be anything. It could be any number, for example, 7. In that case, the variables x1, x2, x3, x4, we get what? This equation is basically telling us that 0 is equal to 7. Okay. In the previous lecture, we discussed that if we have any one of the rows in that echelon form of a matrix or reduced echelon form, then what does it mean? We are getting some 0 is equal to 7, which is not possible, which is a contradiction. In this case, the linear system will not have solution. Okay. But in homogeneous linear system, we already have right hand side 0. We have all zeros here. Okay. So this situation is not possible in homogeneous linear systems. So that's why homogeneous linear system, they must have either unique solution, which is trivial solution, which is 0 solution, or infinite many solutions, because this situation cannot arise here in the homogeneous linear system. So that's why homogeneous linear systems are always consistent. I hope you get it. Any question? Now,
So there's a question in the chat.
जी बोले. You tell me the question. What is your question?
It says, what if you get a number on the left and 0 on the right?
It doesn't matter. You get the value of that variable is equal to 0. You got it? For example, you have some number here 2, some number here -3 equal to 0. So what does this row means? x1, x2, x3. So you have 2x3 minus 3x4 is equal to 0. So this equation makes sense. Okay. Now, when does a homogeneous linear system has unique solution, and when do they have infinite many solutions? If 2x is equal to 0, then x means 0. Yes, it's okay. There's a question in the chat window. Let me see it. Undefined, no solution. What if you get number on the left hand side and 0 on the right side? I hope I have already answered these questions. Let's move forward. Now, if we have a homogeneous linear system, then we can write it obviously in this form. This is homogeneous linear system. Now, if this A is square matrix, if A is square matrix, the first condition is A should be a square matrix. In that case, a linear system can have trivial solution. In this case, when the coefficient matrix is a square matrix. In this case, homogeneous linear system, then homogeneous linear system can have trivial solution. Okay, otherwise no. There is only one possibility for the trivial solution. If A is a square matrix and determinant of A is not equal to 0, or you can say the first condition. Second condition, A is non-singular matrix. Non-singular matrix, कौन सा matrix होता है? You tell me, anyone? Third, A is invertible matrix. Okay. Or fourth condition is A inverse exists. All these four things are same. all these four things are same. If the determinant of any particular square matrix is non-zero, then it must be invertible. If a matrix is invertible, then we can say that that matrix is non-singular, or we can say that inverse of that matrix exists. These all things are in fact same. There's a question in the chat window, or someone has raised the hand. Okay, if you have any comment, if you have any question and any confusion, you can ask me. Why is this so? If a square matrix is invertible, because we can only find the determinant of square matrices. If the matrix is not square, we cannot find its determinant, or we cannot find its inverse. So if the matrix is invertible, then this A times X is equal to 0. You can multiply by A inverse on both sides from the left. Okay, then this A inverse into A becomes identity matrix times X. So A inverse times 0 is obviously a zero matrix, zero vector, and this is again I times X is again X. So what is this? This is the only solution, is the only solution of the given homogeneous linear system. Okay. So when do we get homogeneous trivial solution or zero solution of any linear system? When the linear system is homogeneous and its coefficient matrix is non-singular, or its coefficient matrix is invertible, or its determinant is non-zero. Then we must have, then that homogeneous linear system must have only one solution, which is a trivial solution, or you can say that that is a zero solution, means all the values have, all the unknowns have zero values. Now, in order to get infinite many solutions, is exactly reverse of this thing. A homogeneous linear system must have infinite many solutions if the determinant of the coefficient matrix is 0, is equal to 0. Okay. There are two possibilities in this situation. Let me tell you both possibilities. This is the possibility of unique solution. You can say that trivial solution ki kya possibility hai? Trivial solutions. When do trivial solutions of homogeneous linear systems exist? Under this condition. Otherwise, when do homogeneous linear systems have infinite many solutions? It is basically infinite many solutions. You can write over here. Infinite many solutions. This is the second case. So in infinite many solutions, there are two possibilities. What is the first possibility? If the matrix is square. And the second possibility is if the matrix is not square. Okay. If the coefficient matrix A is square matrix. Okay. Then there are two possibilities from here. First, determinant of A is not 0. We go to trivial solution. Okay. And the second possibility is determinant of A is 0. We go to infinite many solutions. Okay. Infinite many solutions. So if A is square matrix, determinant is not 0, we go toward trivial solution. If determinant of A is 0, we will definitely get infinite many solutions for that homogeneous linear system. Now, the second possibility is if A is not square or rectangular matrix. If A is not square matrix, या आप कह सकते हैं rectangular matrix. Okay. So in this case, we are unable to find the determinant of that matrix because the matrix is not square. So in this case, we always, always infinite many solutions exist. solutions exist. Okay, of, we can say of homogeneous linear system. So these are all the possibilities for the trivial solution and infinite many solutions. If you have any question, you can ask me. There's a question in the chat window, maybe. Bars represents vectors. Okay, Hanzala. If you have any question, Hanzala, you can ask me regarding the vectors. I think I have explained this thing in the first lecture. What is the difference between a matrix and a vector? These bars they represent that they are row or column vectors or row or column matrices. They have only, when a matrix has only one row or one column, then we call it a column matrix or a vector. And we have to put it a bar to represent that this is the column vector or a row vector or a column, a matrix having only one column or a matrix having only one row. So this is basically just a notation kind of thing to describe the vectors, to distinguish between vectors and matrices. Now, this is the whole story about the homogeneous linear systems. Let's have an example and try to find the solutions of any homogeneous linear system. If you have any question, you can ask me. Let me settle this thing a little bit so that you can see things clearly. Okay, let me have some example. Solved by using this one, this thing. Example. Yeah. This one. X1 plus 3x2 minus 2x3 plus 2x5 is equal to 0, and then 2x1 plus 6x2 minus 5x3 minus 2x4 and plus 4x5 minus 3x6 is equal to 0, and 5x3 plus 10x4 plus 15x6 is equal to 0, and then the last equation is 2x1 plus 6x2 plus 8x4 plus 4x5 plus 18x6 is equal to 0. So I don't need to tell you solve this homogeneous linear system. I would just say solve this linear system. You can see that all the right-hand sides of all the equations, they are 0. So obviously it's a homogeneous linear system. Okay. Now, once you know that the given system is homogeneous linear system, then you should adjust your memory and you should revise or remind that what happens in the homogeneous linear systems. Okay. So now the corresponding augmented matrix, first we write the corresponding augmented matrix is sorry. So what is the corresponding augmented matrix? We write here 1, 3, -2, and 0, and 2, and 0. Okay. And the right hand side is also 0. Okay. The next equation is 2, 6, minus 5, -2, 4, -3, and then again 0 here. In the next equation, we have 0, 0, and this is x1, x2, x3. This is 5, this is 10, this is 0, and this is 15 is equal to 0. And in the fourth equation, you get 2, 6, 0, 8, 4, 18, and then 0. Now you get the corresponding augmented matrix. And now you can use echelon form or reduce echelon form. Try to reduce this matrix into echelon form or into reduced echelon form and try to solve it. I hope you can do it. The rest of the method is same. Gauss elimination method, Gauss-Jordan method, either of these two methods you can apply. On this augmented matrix, try to reduce them into echelon or reduce echelon form and solve it by assuming that it's a general augmented matrix and it's a linear system. You use the techniques we have already discussed in order to solve it. Now, after few steps, after applying few operations, I have converted this matrix into echelon form. Now, I'm gonna write the echelon directly, the echelon form of this matrix 1, 3, and I hope you can understand that and you can convert this matrix into echelon form very easily. 0, 2, 0, 0. So this is what I get. I hope you can see it. And then 2, 6, -5, -2, 4, -3, and then 0. 0, 0, 5, 10, 0, 15, 0. And then, sorry. I'm writing the matrix, the wrong matrix. 1, 3, 0, 4, 2. Let me rewrite it. 1, 3, 0, 4, 2, 0, 0. And then, 0, 0, 1, 2, 0, 0, 0, and then 0, 0, 0, 0, 0, 1, 0, and the last row is again 0. The whole thing is 0. So this is, in fact, the reduced echelon form. Can anyone tell me whether it is echelon form or reduced echelon form of this given augmented matrix, which corresponds to the linear system? Whether this is echelon form or reduced echelon form.
I think it's a reduced echelon form.
Reduced. Every pivot entry has a 0 above it and below it.
Okay, that's great.
So
This is
echelon
yes.
form,
Why this is echelon form? Tell me.
because in a reduced echelon form there must be all 0 except the 1 be the first element in each row. Means there would be 0 entries above and below the 1.
Okay, then check whether it is true or not.
So it's true, and since there are no other entries, so there are some other entries that are non-zero. So I think this is not in reduced echelon form.
Do you remember the properties of reduced echelon form?
Yeah, sir.
Try to recall. What is the first property?
The first property is the first element in each row should be
1.
non-zero. That is 1.
Should be 1. ठीक है पहली property true होगी.
Yes,
ठीक
sir.
है. In each row, the first non-zero entry is 1. What is the next property?
For each non-zero, the above row has 1 toward the left.
हाँ, ठीक. 1 towards right. Yes, ये भी property होगी. ठीक है. दूसरी भी होगी. तीसरी क्या है?
For each one, there must be all zeros below and above.
हाँ, तो तीसरी प्रॉपर्टी है 0 के बिलो भी 0 है, सॉरी 1 के बिलो भी 0s हैं और 1 के अबव भी 0 हैं
Yes, sir.
तो फिर क्यों नहीं है रिड्यूस एचेलॉन फॉर्म में? यही 3 प्रॉपर्टीज है ना, तो तीनों प्रॉपर्टीज सेटिस्फाई हो रही हैं. सो दिस इज इन रिड्यूस एचेलॉन फॉर्म. अगर किसी एक 1 के ऊपर फॉर एग्जांपल यहां पे मैं लिख देता हूं 3. Now it is in echelon form. It is not in reduced echelon form. क्यों? क्योंकि हर रो में 1 है, उसके ऊपर और नीचे दोनों 0 होने चाहिए। इस रो में एक 1 ऐसा है जिसके ऊपर और नीचे 0 नहीं है, इसके ऊपर 0 नहीं है सारे। सो दिस इज नॉट अ रिड्यूस्ड एचलन फॉर्म, इट इज एचलन फॉर्म। अगर यहाँ पे 0 है तो तीनों प्रॉपर्टीज रिड्यूस्ड एचलन फॉर्म की सेटिस्फाई हो रही हैं। सो दिस मैट्रिक्स इज इन रिड्यूस्ड एचलन फॉर्म। आई होप यू गेट इट। Okay, we don't look at the other non-zero entries. This entry, we don't care about it. We care only about the entry which is 1. ठीक है, 1 हर रो में 1 होना चाहिए है, हर रो में नेक्स्ट 1 जो है वो राइट पे होना चाहिए प्रीवियस के, वो भी है। हर रो में 1 के ऊपर भी 0 है, नीचे भी 0 है, ऊपर भी 0 है, नीचे भी 0 है। So this is in reduced echelon form. Okay, we don't look at other non-zero entries. We don't care about that. Any question? There's a question in the chat window. Yes. Okay, that's great. Now, we get the reduced echelon form of the given this augmented matrix. Now we write back the linear system. We write back the homogeneous linear system. In fact, we will get x1 plus 3x2, okay, plus 4x4 plus 2x5 equal to 0. And then from here, x3 plus 2x4 is equal to 0. And then from here, x5 is equal to 0. Okay, so this is the corresponding homogeneous linear system.
Sir, the last one
Shouldn't
is
this be
X6.
X6?
X6.
Huh? X
So the third equation is X6.
तो x6 ही लिखा हुआ है यार, गौर से देखो। चल
Okay,
ठीक
sir. Okay.
अब हमारे पास टोटल वेरिएबल्स कितने हैं? अननोन 6। इक्वेशंस कितनी हैं? 3। जितनी इक्वेशंस होंगी उतने वेरिएबल्स की वैल्यूज फाइंड होंगी। रेस्ट ऑफ द वेरिएबल्स वी हैव टू सेट देम फ्री वेरिएबल्स। ओके, नाउ x6 की वैल्यू डेफिनेट है, x3 की वैल्यू, x1 की वैल्यू। जो आपके पास पिवट एंट्री होती है ना, दिस इज योर पिवट एंट्री, इसके कॉरस्पॉन्डिंग जो वेरिएबल्स होंगे उनकी वैल्यूज आएंगी। वी कैन फाइंड द वैल्यूज ऑफ द अननोन वेरिएबल्स कॉरस्पॉन्डिंग टू द पिवट एंट्रीज। All other variables we have to set them as a free variable. This is the standard procedure, but you can fix any 3 variables you can set any 3 variables as free variables. It's not basically a mandatory condition, but it is the practice, usual practice, that you find the values corresponding to the pivot entries, and rest of the variables you have to set them free. It's a usual practice. It is not mandatory. Okay. So now x6 की वैल्यू है हमारे पास, x3 की वैल्यू हम फाइंड कर लेंगे in terms of x4, और x1 की वैल्यू फाइंड कर लेंगे हम in terms of x2, x4 and x5. So we have to set x2, x4 and x5 as free variables. Okay, we don't have any other choice. So let's fix their values as free variables. So x1, 3x2. So x1 plus 3x2 plus 4x4, and what next? 2x5 plus 2x5 is equal to 0, and x3 is basically आप इसको in terms of that thing find कर लें. So x1 is equal to negative this, and negative this. और x3 की वैल्यू क्या आ जाएगी? negative 2x4, negative 2x4, and then x6 की वैल्यू 0 है। ठीक है, so you have found the value of x1, x3 and x6, and you have to set x2 as a free variable, x4 as another free variable, and x5 as some other free variable, where T belongs to R, and R belongs to R, and S belongs to R. Now, you have the complete solution, which is infinite many solution. Now you can write basically the parametric form, the complete parametric form of the solution, x5, x6. So what do you obtain here? It is negative 3x2 is what? T. Negative 4x4 is what? It is R. Negative 2x5 is what? S. Okay. And then x2 is what? X2 you set there, it is T. And x3 is what? It is negative 2x4. X4 is R. And x5 is what? No, x1, x2, x3. Okay, x4 is what? X4 is R. X5 is S. And x6 is 0. So this is your solution of that corresponding homogeneous linear system, which are infinite many solution in fact. And further, you can divide, you can separate the constant terms. There is no constant term here because the right hand side is 0. So we can take common t here. The coefficient of t here is negative 3. Here is 1. यहाँ पे नहीं है, तो आपके पास ये आ गया, ठीक है? प्लस फिर r का कोफिशिएंट कॉमन ले लें, r का कोफिशिएंट यहाँ पे, so यहाँ पे x r नहीं आएगा, यहाँ पे r आएगा only. Mistake here. So r का कोफिशिएंट पहले वेक्टर में क्या, पहले में क्या है? नेगेटिव 4, दूसरे में 0, तीसरे में 2, चौथे में 1, पांचवें में नथिंग, छठे में नथिंग. फिर आप s कॉमन ले लें, and s is the coefficient of s is negative 2, यहाँ पे 0, यहाँ पे 0, यहाँ पे 0, यहाँ पे 1, यहाँ पे 0. So this is the parametric form of your solution of that corresponding homogeneous linear system. I hope you get it. If you have any question, you can ask me. No. No questions? Okay, let's move forward then. There's a theorem here, or there is a result here. Let me write that result for you, which help you to basically define number of free variables. There is a result, or you can say a theorem. Okay. That theorem is a homogeneous linear system with more unknowns than equations has infinite many solutions. It is obvious. I told you already. A homogeneous linear system with more unknowns than number of equations has infinite many solutions. It's a theorem. You don't need to prove it. You just know it. Now, another theorem is, which I have written here on the page 16, on the slide 16 of lecture 2. If a homogeneous linear system has n unknowns, if a homogeneous linear system, HLS, has n unknowns and if the reduced echelon form of its augmented matrix has R0 rows, then the system has n minus r free variables. So this. I think this theorem is not complete here. It doesn't give us complete information. हाँ ठीक है ठीक है ठीक है ठीक है. If in a previous example we have n unknowns, ठीक है, यहाँ पे नॉन जीरो आना चाहिए, नॉट जीरो. मैं भी यही इसीलिए परेशान था कि यहाँ पे नॉन जीरो आना चाहिए, नॉट जीरो. आर नॉन जीरो रोज. ओके, अब ये थ्योरम, ये वाला रिजल्ट जो है आप प्रीवियस एग्जांपल पे अप्लाई करें. अगर किसी भी होमोजेनस लीनियर सिस्टम में n अननोन है और उसका रिड्यूस एचेलॉन फॉर्म उसकी कॉरेस्पॉन्डिंग ऑगमेंटेड मैट्रिक्स की, अगर उसमें r नॉन जीरो रोज हैं, r नॉन जीरो रोज हैं, तो उसमें आपको कितने फ्री वेरिएबल्स इंट्रोड्यूस करने पड़ेंगे? n minus r. Let's apply this theorem on the previous example here. About us, this is the homogeneous linear system. It has more unknowns than equations. Okay. When after converting its augmented matrix into reduced echelon form, how many non-zero rows are there in this reduced echelon form? There are only 3 non-zero rows. So total variables are 6 and non-zero rows are 3. So we must have to introduce 6 minus 3, which is 3 free variables in the solution of the corresponding homogeneous linear system. So it is true. Okay. I hope you get it. If you have any question, you can ask. You people don't have any question?
Sir, इसमें
जी जी
go
बोले.
ahead.
जी जी go ahead.
Sir, 6 variables minus 3 non-zero rows, right?
जी जी.
Okay, sir. Thank you.
The other one?
Sir, इसमें 3 non-zero rows तो नहीं है.
3 non-zero है ना. Pivot element
अच्छा.
जिसमें है वो non-zero row है ना basically. 1
सही,
2
सही.
3. Non-zero row
सही.
3 है ना. चौथी row
सही.
0 है. So 6 minus 3 is equal to 3. 3 variables you have to introduce as free variables.
ठीक.
Now we are finished with, for the time being, we are finished with linear systems, Gaussian elimination method, Gauss-Jordan elimination method, non-homogeneous linear systems, and homogeneous linear systems. These are two kinds of homogeneous linear systems which we deal with these two kinds of methods, Gauss elimination method and Gauss-Jordan elimination method. Okay. Now let's start discussing a little bit about matrices, their inverse of a matrix and determinant of a matrix. Okay, we are going to start this thing now. Let me erase this thing. Meanwhile, you look at the solution of that corresponding homogeneous linear system. If you have any question, you can ask.
Excuse me, sir.
जी बेटा. जी बोले.
सर वो पिछले बोर्ड पर 1 मिनट दें.
इससे जो पीछे या ऊपर है?
सर पीछे प्रीवियस वाला जो था सर.
ये this one. बोले.
सर अगर वो लीडिंग एंट्री जो थी, अगर फर्स्ट कॉलम पूरा 0 होता है तो कितनी नॉन जीरो रोज होती?
अगर फर्स्ट कॉलम सारा 0 है, ले लें इसको 0, नो प्रॉब्लम. ठीक है, यहाँ पे भी 0, यहाँ पे भी 0, यहाँ पे भी 0, यहाँ पे भी 0. फिर हम ट्राई करते इसको लीडिंग 1 बनाना, 3 वाले को, यहाँ पे 1 होता, इवन देन 3 नॉन जीरो रो होती। पूरी रो जब तक 0 नहीं है उस वक्त तक हम उसको 0 रो नहीं कहेंगे। कोई एक भी एंट्री, ये वाली जो आखिरी रो है ना, दिस इज योर 0 रो। ये वाली जो सेकंड लास्ट है ये नॉन जीरो रो है, क्योंकि एटलीस्ट वन एंट्री शुड नॉट बी 0। ओके, देन वी कॉल इट नॉन जीरो रो। You got it?
Yes, sir.
Okay. Now, I hope you know what is the matrix and some of the basic properties of matrices. I'm not going to tell you. For example, let's review the definition of a matrix. You can read the definition I have given in my slides and notes as well as you can read them from the books I have uploaded on LMS. A matrix is
So
a
where are the
rectangular
slides?
array. स्लाइड्स भी मैंने LMS अपलोड की है LMS में। लेक्चर स्लाइड्स का एक फोल्डर बनाया हुआ मैंने, ठीक है,
सही।
एक लेक्चर स्लाइड्स का फोल्डर है, एक लेक्चर नोट्स का फोल्डर है, ठीक है,
सही।
दोनों में डिफरेंट है। और एक बुक्स का, रिकमेंडेड बुक्स का फोल्डर है, उसमें बुक है
जी, वो देखा।
यू कैन सी ऑल दीज 3 फोल्डर्स, देयर आर स्लाइड्स इन दीज फोल्डर्स। ओके,
ठीक है, थैंक यू।
So a matrix is a rectangular array, ठीक है, which has constant values. Maybe for the time being, you can only say that there are constant values in the matrix. There might be some variable, there might be complex numbers as well. But in this course, it's basically a first course of linear algebra. So you can take a matrix as a rectangular array having real numbers as entries. So you can say that this is maybe 11, -2, 1, 0, 5, 2, 3, 8, and -2, 3, 4, 5. So this is in general a matrix. A matrix may have different number of rows and columns. So this is basically, this is the first row, and this is the second row, this is the third row. And these, in this way, we say that these are the column of a matrix. All you know these things. A matrix, let me clarify the confusion of students about matrices and vectors. So the order of this matrix, we denote matrices by capital alphabet letters. Okay? Matrix can be a square matrix, for example, 2, 3, 5, -1. A matrix having equal number of rows and columns, that is called a square matrix. Okay? And a matrix having rows and columns not equal, then we call it a rectangular matrix. A matrix having, for example, any matrix C having only one column, 1, 2, 3, for example, this is called a column matrix, or we call it a column vector. Okay. And we do not denote it just to differentiate between row matrix or a column matrix from the other usual matrices, rectangular or square matrices. We denote these kind of row vectors and row columns, column vectors by small letters having bar on it. Okay? So we call them usually vectors, just to make the compatibility in the notations of vectors and a matrix having only one column or one row. So similarly, you can write another matrix which has 1, 3, 5, 9, have only one row. So technically, the order of this matrix is what? 3 cross 1. It has 3 rows, 1 column. And this matrix have technically order 1 cross 4. It has 1 row and 4 columns. So we call it a row vector, or simply a vector, or a row matrix. Okay. So this is the difference between the usual matrices and the vectors. I hope you know how to multiply 2 matrices. When 2 matrices can be multiplied, there is a criteria for this. I hope you know it. If someone can remind me, what is the criteria for multiplying 2 matrices? Anyone?
I think the columns of the first matrix must be equal to the rows of the second matrix.
Yes. So if we have two matrices, for example, this is the matrix A, its order is what? It has 3 rows and 4 columns. And this matrix has 2 rows and 2 columns. So if we want to find the product of A and B, then we need to investigate their orders. Okay, first we write the order of A, 3 cross 4, and then order of B, which is 2 cross 2. So these two things must be identical. The column of first matrix should be equal to the rows of the second matrix. Okay, these two things must be same. Otherwise, those matrices are not multiplicable. If this is true, the resulting matrix after multiplication, we get a matrix of order 3 cross 2. Okay, if we multiply AB and get some other matrix C, not C, but this one, you can say some other matrix, some K matrix, then the order of K after the multiplication of AB must be what? 3 cross 2. Okay, this is the rule. Now, if you look at A and B, these two matrices are not multiplicable. Okay, but if we see A and C, whether they are multiplicable or not. So order of A is what? 3 cross 4. Order of C is what? 3 cross 1. Okay, so these two things are not equal. The column of first matrix and the rows of second matrix, they are not equal here. So these two matrices are not multiplicable. If we write another entry here, 1, 2, 3, and some other entry, maybe 5, then what would be the order of C? The order of C becomes now 4 rows, 1 column. So this is 4 cross 1. Now you can see that the column of the first matrix is equal to the rows of second matrix. These two things are equal. So A and C are multiplicable. And the resulting matrix, which we obtain, whatever the matrix is, maybe P matrix, its order should be what? 3 cross 1. So it is again a vector. Okay, because it has 3 rows and 1 column. This vector should be some kind of matrix of this kind, which is a vector. I hope you know how to multiply two matrices. If someone does not know, he can tell me. He can ask me. I'll give you an example, and rest of the things you can read yourself from the book. It's because you have already studied these things. I don't want to waste a lot of my time on these very basic things. Anyone who doesn't know the multiplication of two matrices? जी
सर एक एग्जांपल दे दें ताकि रिफ्रेश हो जाए अगर छोटा सा कोई
So वैसे just in case, could this be done in the tutorials as well?
Yes, that can be done in the tutorial as well. I'll advise the TAs to revise these basic concepts of multiplication and some other basic concepts. Okay. You're gonna have tutorial today, I think, on HLM and reduced HLM form, because tutorials have already been started. So try to participate in those tutorials and try to solve your confusions, and you would definitely see examples of the topics which we are covering in lecture. I don't have, unfortunately, much time to give you several examples for one topic due to the shortage of time. So the examples would be covered in the tutorial. So try to attend tutorials. Don't miss them. They are equally useful as the lecture. Now, let me have two matrices. Maybe A is some matrix, the same one, maybe, no. 1, 3, 5, and 2, 4, minus 1. This is a matrix, and B is some other matrix, 2, 3, minus 1, minus 5. Now, you can see that the A is a matrix of order 2 cross 3, and B is a matrix 2 cross 2. They are not multiplicable. Now, what I do here, let me change the matrix A a little bit. Instead of having one more column, let me write another row of that matrix A, maybe -3 and 5. Okay, so this one. Now the order of this thing, this matrix A is what? 3 rows and 2 columns. And order of B is 2 rows and 2 columns. Now you can see that order of A is basically what? It is, you can say 3 cross 2, and order of B is 2 cross 2. So you can see that these two things are equal. आप यहाँ पे वैसे ही order लिख लिया करें check करने के लिए. So 2 cross 2, order of A is 3 cross 2 and this. So these two things are equal. So the product is possible here, and the resulting matrix should be 3 cross 2. Okay. Now, how to multiply A and B? You first write A here, 3, 1, 3, 2, 4, -3, 5, and then you write here 2, 3, -1, -5. Now, how do you multiply them? You take the first row of the first matrix, this one, and multiply it with the first column of the second matrix. Okay, that is why the columns, there are, how many columns are there? 2. And how many rows are there? 2. They should be compatible. They should be equal so that we can multiply them. So we then multiply the respective entries in this row and column with each other, and then we add them. For example, we multiply first entry with first here and second entry with second here. So what do we do here? We multiply 1 with 2 and 3 with -1. Okay, and then we put them, put a plus sign here in between them. First entry, multiplication of first entry with first here and second with second, and then we add up them. So this will be the first entry of the product of these two matrices. Now here, the second entry, what do we do here? In order to get the second entry, you again get the first row of the first matrix and the second column of the second matrix. So first row and second column, we multiply first entry with the first plus second entry with the second, or third entry with the third, and so on. So next, now you take the second row. Now first row has been finished. This is how it works. First row, first column, first row, second column, first row, third column, and so on. This is how we write the entries of the product. Now, first row has been multiplied with each column in the other matrix. Now we choose the second row in order to get the second row here of the product. Second row, first column, second row, second column, and then second row, and so on, next columns. But here we have only 2 columns. So now we choose the second row, multiply these entries of second row with the first column, entries of first column. So you multiply first with first, second with second, and add them. So this is how 2 cross 2 plus 4 cross -1. Now, you take again the second row and second column now. Okay, we multiply them 2 cross 3 plus 4 cross -5. Now, second row now has been finished because the columns are now, there are no more columns here. Now you choose the third row, and third row multiplied with the first column, third row, second column, and so on. So this is how you write -3 multiplied by 2 plus 5 multiplied by -1, and then -3 multiplied by 3 plus 5 multiplied by 5. Now you have to simplify them. You have to simplify them, and here you get 1 into 2, 2, -3. 2 -3 is -1. So you get 3 here and -15 here. So you get -12 here. So here you get 4, here you get 4 negative, you get 0 here. And here you get 6, here you get -20, you get -14. Here you get -6, -5, -11, and then -9 and -25. So it is -34. What is the order of this matrix? How many rows are there? 3. And how many columns are there? 2. So I told you, if the columns of the first matrix are equal to the rows of second matrix, the matrices are multiplicable, and the resulting matrix after the multiplication we obtain is of order 3 cross 2. So 3 cross 2. So this matrix is basically, in fact, of order 3 cross 2. So it is the correct multiplication. So this is basically A into B. I hope you get it. If you have any question, you can tell me. Try some other examples from the book as well as from the lecture notes and slides. If you've got any confusion, you can ask me in the next lecture. Now, next thing, which is most important thing in matrices, the most important thing in matrices is that A multiplied by B is not equal to B multiplied by A. The most important result in matrices is that matrix multiplication is not commutative. Matrix multiplication is not commutative, means A into B is not equal to B into A. And in real numbers, you say that 2 cross 3 is equal to 3 cross 2. They both are 6. 2 into 3 or 3 into 2. They are commutative, means their multiplication is commutative. But matrix multiplication is not commutative. If you can find A into B, then it is not always necessary that you can find also B cross A. For example, here, in A cross B, the order is what? 3 cross 2 and 2 cross 2. Okay. So columns of first matrix, they are equal to rows of the second matrix. They are multiplicable. But if you change the order here, you write B cross A. You want to find the B cross A. What is the order of B? It is 2 cross 2. And what is the order of A? This is 3 cross 2. Now, these two things are not equal. So we cannot find B cross A, B into A. It is not possible to find it. Even we cannot find it, then how we can check whether they are equal or not? Okay, they are obviously not equal because the second B into A is not possible. And what is the definition of equal matrices? Two matrices are equal only if their orders are equal and their respective entries are also exactly same. Then we say that two matrices are equal matrices. So if you want to check whether AB is equal to BA, then we have to calculate them separately, and then we have to check all the respective entries. In each row and each column, all the entries, they should be identical in both matrices. Then we can say that these two matrices are equal. Let me write the definition of equal matrices somewhere here, but I hope you get it. Let me raise that board, and then I shall write somewhere. Even if the orders, even if the multiplication is possible in the product. For example, if A is of order maybe 1, 2, 3, 4, and B is again is of a square matrix of same order, maybe minus 3, maybe 6, 9, 11. Okay. Now, AB and BA, both multiplication is possible. AB and BA, both multiplication is possible because the number of columns in the first matrix is equal to the number of columns in the second matrix in both cases. But even then, it is not necessary that AB is equal to BA. It might be, it may be equal and it may not be equal. So in general, we say that matrix multiplication is not commutative. AB is not generally equal to BA. And two matrices A and B are equal, yeah, if The orders of A and B are equal, as well as their respective entries are equal. Means all the entries in B should be exactly same as 1, 2, 3, 4. Then we say that A is equal to B. If their order is same and the respective entries must be also same. I hope you get it. If you have any question, you can ask me. The next is a kind of, let me tell you different kind of matrices which we are going to encounter or which you will see in the upcoming lectures. Identity matrix. Identity matrix is basically denoted by I, and it can be a 1, 0, 0, 1, a 2 cross 2 matrix, then we write it I2. Identity matrices are always square matrices. We cannot write a rectangular matrix as an identity matrix. Okay, identity matrix are always square matrices. Their order of rows and columns must be same. This is your I2. If I want to write I3, means order 2 cross 2 order है इसका. I3 means order of 3 cross 3, mean it has 3 rows and 3 columns. 1, 0, 0, 0, 1, 0, 0, 0, 1. So if you want to write I4, I hope you can write it 1, 0, 0, 0, 0, 1, 0, 0, and 0, 0, 1, 0. Fine. So identity matrix have 1 in the diagonal, in the diagonal of this matrix. This is called diagonal of a matrix, main diagonal of a matrix. And the other way around, this is called the off diagonal, or you can say, so not off diagonal. This is the main diagonal. The other one is, you can say, not main diagonal. I don't know what is exactly its name. Another matrix, for example, A, where we don't have ones in that main diagonal. You can have 1, 2, 3. Okay. This is called a diagonal matrix. Okay. And another matrix in which the diagonal entries are same. For example, 3 cross 3, 3, 3, all other zeros. This kind of matrix is called a scalar matrix. Another kind of matrix is a lower triangular matrix and upper triangular matrix. Okay. A matrix of this form where all the entries below the diagonal are 0. For example, 1, 2, 2, 2, maybe 7 here, 8, 9, 11. But here, these entries, the entries below this diagonal, if the entries below this diagonal is they are all 0, then we call it upper triangular matrix. Upper triangular matrix. And reversely, if we have, you can denote it by U as well. And because it's upper triangular matrix, you can say this is U, and the other one is L. There's a lower triangular matrix where you can have 1, 3, 5, 0, 0, 0. And here you have maybe -2, -3, or 8, or maybe 1, anything. Now you can see that this is the lower triangular matrix because all the entries above the diagonal, main diagonal, are 0. So this is called lower triangular matrix. I hope you get it. If you have any question, you can ask me. Another kind of matrix is a symmetric matrix. A matrix, बल्कि पहले इससे couple of things I want to tell you. What is the trace of a matrix? Trace of a matrix. Trace of a matrix is sum of all diagonal entries of a matrix is called trace of a matrix. Okay. And it is denoted by TR of A. Okay, if A is the matrix. For example, that is A is some matrix we have written over here, and trace can only be found of a square matrix. A should be a square matrix. Okay. Otherwise, it would be difficult to find the trace. We cannot find in fact. Now, if U is some matrix, then what would be the trace of U? The trace of U is 2 plus 2 plus 9, 13. Okay, so you can say that trace of that U is what? 9 and 4, 13. So trace of that U matrix is 13. Sum of all diagonal entries is called a trace of a matrix.
Sir, I have a question.
G.
Sir, for upper or lower triangular matrix, sir, all the elements above or below the matrix should be non-zero, or if, for example, if there is
some may be zero. Okay, you can say at least one should be non-zero. They should be non-zero. At least one should be non-zero. Okay. Other might be zero. But in the upper section, above this diagonal, all must be zero. If at least one is non-zero, then we cannot say that this is a low triangular matrix. Okay. I hope you get it.
Yeah.
Now, the trace of a matrix, now we are going to discuss what is the transpose of a matrix. In a transpose of a matrix, what we do, we interchange the rows and columns. Transpose. Transpose of a matrix or matrix transpose. If we have any matrix, for example, A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then if we want to take the transpose, and it is denoted by A power A superscript T, sometimes they write capital T or sometimes small t. So the transpose of a matrix, what we do, we interchange rows and columns. So for example, this is the row, we make it column in the transpose, 1, 2, 3. So this is again row, we make it column, 4, 5, 6. So this is again 7, 8, 9 is a row, we make it 7, 8, 9 here. Okay, we convert rows into columns. So this is what we call, it is a transpose of a matrix. Okay, if you have any question, you can ask.
So to find the transpose of a matrix, should the matrix always be a square matrix?
Yes, all these matrices should be square matrices. Lower triangular, upper triangular. Okay, all these matrices should be square matrices. Okay, transpose is also a square matrix. Now, next is symmetric matrix. Its basic definition is, if a matrix transpose is equal to itself, then that matrix is called a symmetric matrix. For example, if I write A is equal to maybe 1 to maybe 3, 0, 0, 5, 5, and maybe -1, -1. So if you take up, जरूरी नहीं है यहाँ पे 0, it could be some other number as well. 0 यहाँ पे आप 4 लिखते हैं, for example, यहाँ पे 4. Now you take the transpose of this matrix. What will be the transpose? Can anyone take the transpose and tell me what would be the transpose?
So in the first column, you will have 1, 4, 5.
So this is your 1, 4, 5 row. You get 1, 4, 5. So in fact, 1, 4, 5 is the same column, row and same column. Now the second second row and second column, they are exactly same. So whatever you do here, second row ko second column mein likh denge, you get the same thing. So U4 to -1. Similarly, third row and third column, they are same, identically. 5 minus 1, 3, 5 minus 1, 3. So it doesn't change anything. 5 minus 1, 3. So this A transpose is exactly equal to A. So we call it a symmetric matrix. Okay. All the entries around the diagonal are symmetric. You can see that. In a diagonal, you can put anything, but all the off diagonal entries, this entry should be equal to this. This entry should be equal to this. The corresponding entries should be identical. Okay. You can see here, the diagonal entries, they could be anything, but this entry and this entry, this entry, this entry, they should be same. You can see that. If you can see this, then the matrix is symmetric matrix. Yes.
सर आई डोंट थिंक तो कि सिर्फ स्केयर मैट्रिक्स का ही ट्रांसपोज ले सकते हैं सर 2/3 ऑर्डर के मैट्रिक्स का भी तो ले सकते हैं
हाँ, you are right. But usually here in this transpose मेरे ख्याल में rectangular का भी ले सकते हैं. You are right. I'm sorry for that. Transpose के लिए जरूरी नहीं है कि आपका मैट्रिक्स स्केयर हो. ठीक है. It may be not square. Maybe not square. It could be square, but for the symmetric matrix, for the symmetric matrix, the matrix should be square. I was thinking about symmetric matrix while telling you about the transpose. That's why I thought it should also be square matrix. If you are only interested in transpose, then transpose can be taken of any non-square matrix as well. For example, if you take the transpose of a row vector, it would become a column vector. For example, x is a column vector, maybe 1, 2, 3. Then x transpose is what? X transpose is what? It will be a row vector, 1, 2, 3 of this kind. Okay. Then even the transpose of a row vector or a column vector is also possible. Whereas for a symmetric matrix, the matrix should be a square matrix. I hope you get it. If you have any further question, you can ask me. Otherwise, these are some basic matrices and type of matrices which I have told you. Try to read the other properties and kind of matrices from my notes as well as slides. So for today, I'm going to stop it here. If you have any question, you can ask me. No questions?